guys, so now we've learned about 3 laws and we've done labs with 2 of them. PV equals K, Boyle's law. V over T equals K, Charles' law. P over T equals K, Gay-Lussac's law. And then we've drawn graphs that go with each of them. But what would happen if I combined all 3 of those things? Because I don't know if you remember when we did the PhET activity, but you notice that it's very hard to hold one constant while the other 2 are changing. Generally, if you increase temperature, you're going to increase pressure, and then if you increase pressure and the thing is elastic, the volume might want to change. So what law would combine all 3 of these? Well, I'm so glad you asked, because I'm here to tell you that that law is called the combined gas law. And we don't need to be very smart to be able to take these 3 laws and combine them into one. Why? Because we know that the relationship between P and V is an inverse. We know that the relationship between V and T is direct. And we know that the relationship between P and T is direct, which leads us to placing all 3 values in one formula and giving us the combined gas law, which is P times V over T equals a constant, or P1 V1 over T1 equals P2 V2 over T2. Now, the hardest thing about this is just not getting your symbols confused. The math is pretty straightforward if you've had Algebra 1. And the concepts are pretty straightforward based on what we've done previously. So let's jump right in and let's try this problem right here. It says if a gas has a volume of 4.2 liters, so that's going to be our V1, under a pressure of 109 kilopascals, so this goes with this, so this is going to be our P1. And a temperature of minus 10 degrees Celsius, that's going to be our T1, and we know we need to add 273 to that to get it to Kelvin, so that's going to be 263 Kelvin. So these are all our ones, our V1, our P1, our T1, that's how they exist at that moment in that system. Then the question says, what will be its new volume? So volume 2 is going to be our X value, our unknown. At 90 kilopascals, that's going to be our P2 value. And 25 degrees Celsius, that's going to be our T2 value. I'm going to add 273 to that. That's 298 Kelvin. So now we're going to plug and chug. So here we go. P1 V1 over T1 equals P2 V2 over T2. Let's plug the numbers in carefully. 109, 4.2, 263, 90, X, 298. And then we're going to map that out. You can do this a number of ways, but whatever is most comfortable to you, whether you multiply and then divide, or divide and then multiply. But when you math that out, I'm going to pause the video for 5 seconds and give you a chance to do that. You should get a value of V2 equals 5.76 liters. Now, if we look back at our problem, we're only allowed, there's 2, there's 3, there's 2, well, 1 or 2, there's 2, there's 2. We're going to count those as 2. So we're going to say you're only allowed 2 sig figs. So my final answer is going to be 5.8 liters. Now let's see, does this make sense? I started out and I had a pressure of 109 and I had a really low temperature of 263 Kelvin. I heated it up so it got hotter, but I decreased the pressure. So I would expect that my volume should increase, and voila, my volume should increase, and it did. Let's try another one. If a gas has a volume of 6 liters, there's my V1. under a pressure of 115, there's my P1, and a temperature of minus 15 degrees, there's my T1. What will be its new volume at STP? Well, goodness, they didn't give me very many numbers at the end, so I'm a little concerned, but let's go ahead and let's list our givens. B1, 6.0 liters, P1, 115 kilopascals, temperature T1, minus 15. I'm going to add 273 to that, and I'm going to get 258. That's now in Kelvin. Then my V2 is X. My P2 is I have no idea because they didn't tell me. And my T2 is I have no idea because they didn't tell me, or did they? STP stands for standard temperature and pressure. So standard temperature is always going to be 273 Kelvin. And standard pressure is always going to be 1 atmosphere or 101.3 kilopascals or 760 millimeters of mercury. So which one do I choose? Well, I just go back in my problem and I'm like, oh, they gave me kilopascals, so I'm going to choose this one. So standard pressure is 1 atmosphere, 101.3 kilopascals, or 760 millimeters of mercury. T2 is standard temperature in this case, which is 273 Kelvin. And then I go through and I just plug and chug again. P1 V1 over T1 equals P2 V2 over T2. Plug the right numbers into the right locations. P2 is 101.3 X and 273. And then you're going to solve for X. And I'm going to leave you to solve for X on that one yourself. Just remember that the biggest thing here is remembering what STP stands for. And also remembering that you have to pick the pressure value that matches the pressure in your other given. Otherwise, it won't work out because you have to compare apples to apples, or in this case, kilopascals to kilopascals. So that's the combined gas law. And in the combined gas law, all we're doing is using volume, pressure, and temperature. Now, some students start thinking about this a little bit deeper, and they're like, well, why do we even need to know, okay, this is Boyle's law, and this is Charles' law, and this is Gay-Lussac's law, when we have a combined gas law? And they say, couldn't we just always use this one? And the answer is yes, if you're being smart about it. Why? If they just give you a pressure and a volume, then you're going to keep your temperature as 1. So then you're just doing P times V. If they give you a volume and a temperature, then you're going to keep your pressure as 1 because it's staying the same. So you can completely do that. You can always use the combined gas law for all your problems. Just remember that the quantity that they didn't give you any values for, you're going to put that as 1 because it's not changing, it's staying the same. So even if it had a value, because it's staying the same, it's not going to affect anything. Okay? So that's the combined gas laws. And the next time we meet, we will talk about how to find the moles of a gas.